So let's get started. Welcome to my talk. It's a word about programming, where I apply a natural language vocabulary acquisition model to programming education. Oh. I think that doesn't work. Well, first of all, Felienne already said I'm one of her students. I want to talk a bit about my background, because I have a background in language and literature. I also have a master's in education, and now I'm doing a PhD on computer science education. But, you make me nervous. So I know about teaching language, and I know about learning language. In high school, I had 6 languages. I had Dutch, English, Greek, Latin, German, and French. And I really enjoy learning. So 6 years ago, I thought I tackle another challenge. I'm going to learn a 7th language, Java. And it was quite different from what I was used to in natural language learning. Because I was sitting in class, and there was this teacher, and he was talking about programming concepts, and he coded live on screen. And then he said, well, here's your assignment, now do it yourself. And I thought, well, we know a lot about language learning, and we know a lot about natural language learning. Why don't we take a look at that and use it for programming language learning, since it's also a language? For this research, I took a natural language vocabulary acquisition model, and I applied it in a programming education class. So first, let's take a look at the model. It consists of 4 phases. You have a preparation phase, in which you create a context to learn new words. You have a semantization phase, where you provide meaning to the words. A consolidation phase, where you repeat the words in various ways at various times. And then at the end, a verification phase to see if words are really remembered and stored in long-term memory. There are several techniques and exercises you can use to really make sure words are correctly learned. And those techniques are either non-verbal or verbal, and receptive or productive. So it all makes sense, right? Well, I decided to bring an example. I'm going to teach you a Dutch word. It's the word stroopwafel. It's a stroopwafel is depicted here. I also brought a stroopwafel, so you can take a look at it. Yeah? A stroopwafel is a kind of cookie. It's just like a chocolate chip cookie or an Oreo. So that's how it's related to other words. In English, I think it's called a treacle waffle. And it consists of 2 layers of dough with some syrup in the middle. And actually, stroop means syrup, and wafel means waffle, so it makes sense. And when you create a sentence with the word, for example, you can say something like, because it's her birthday, the researcher gave everyone in the audience a stroopwafel. Keep this in mind, I will come back to this. All right, so I thought, what if you apply this to programming concepts? What if you use keywords and also use this framework to really teach students the words and how to use the words in a sentence? So we went to a class with 12 to 13-year-old students. They had an introductory programming course in their curriculum. They also have natural language courses in their curriculum. And the class consisted of 26 students, both boys and girls. We used Heddy, but I decided not to elaborate on it because you probably heard a lot about Heddy today. And we substituted 3 of their regular lessons with lessons in which we used this framework. The students were used to what I was taught when I learned Java. They were used to getting concept explained, watching the teacher code, and then do it themselves. So we substituted the lessons, and we made sure to include paper handouts to have them practice the concepts. All right, we did lesson observations, we analyzed the students' work, and we also asked them for feedback, both written and verbal. All right. I want to show some results with you. First of all, the learning goals are met. I know some of you probably think, well, this is not like it's supposed to go in a programming class, but learning goals are met. The students learned and practiced programming concepts effectively. Also, we noticed that with the pre-intervention lessons, students adopted more of a trial and error approach. They would write some code, run it, oh, error, fix something, run it again, oh, error, and they just kept on trying. Well, in our lessons, students were talking to each other, talking to the teacher, asking questions. They were really engaged with the assignments. And when they put it in paper, you can also see there are not a lot of corrections on the handouts because they really thought about what they wanted to answer, what they wanted to put down on paper. They did not like working on paper. Actually, they hated it because it's programming, we have to work with computers. So they showed a great dislike for working on paper. And also, a lot of time, we asked them to associate and brainstorm and talk to each other about the programming concepts. So a lot of time they were asking, will this impact our grade? And we had to reassure them, no, it's just so you learn better, in a better way. And something noteworthy is students reported they had a lot of fun. They, for example, one student said, it was more fun than a usual lesson when we get instruction and work out on our own for the remainder of the lesson. This lesson was more fun and challenging. But negative, we had to work on paper a lot. Another student, I think coding is super hard, but it was fun and entertaining. We had a fun lesson today. But it is difficult to understand. Those are illustrative examples of student feedback. Something else we really did not expect, because they had to work on paper, right? And they started to use syntax highlighting. And they did it spontaneously. We didn't ask for it. So we just gave them the paper handouts, asked them to write some code, and they got their markers and added syntax highlighting by themselves. And I think this is probably a girl. I think this is probably a boy. Here you see this student didn't have any markers on them, I guess, but they highlighted the keywords, so they added some structure to the code, just like syntax highlighting would do on a computer screen. All right, so we had success in achieving the lesson objectives. We had high levels of motivation. Students had a lot of fun during the lessons. We do need to make sure there's a safe classroom environment in which students can freely brainstorm, associate, talk to each other without having to worry about it impacting their grade. And they showed a great dislike for working on paper. But we want to improve these lessons and include syntax highlighting because I think if students see the added value of working on paper, really work with exercises that include syntax highlighting, it also helps with their motivation. All right, so I was talking about those 4 phases: prepare, semantize, consolidate, and verify. The verification phase usually takes place later because you really want to check if words are stored in long-term memory. And what was this called? Thank you. Because it actually is my birthday today, I brought you stroopwafels so I can celebrate with you. Can you? Thank you. Can you pass it along? All right, are there questions?
So yeah, a very interesting idea with the teaching like the programming similar to like you would teach natural language. I was wondering, since like a Strootwafel is something like everyone knows like from the surrounding, it's very easy to imagine and everything, and like a programming concept is like a lot more abstract, right? So it's kind of hard to envision, like you don't know it from your everyday life. And so I was wondering how you tackle this challenge.
Yes, that's an excellent question, because it actually is a challenge, and it took a lot of thought before I came up with examples. But in one of the lessons, for example, we introduced if and else, and I used the technique of visualization, and I asked students to write down a flowchart or a decision tree based on their own lives, so they could really see how an if-else construction works. And then they had to translate it to real code.
So thanks a lot for the paper and bringing novel ideas to teaching programming. I'm wondering about the disliking working on paper part. Are students at the age of 12 or 13 in the Netherlands used to working on iPads, tablets, something in their other lessons? Or is it because there was a recent shift in Austria? So I'm wondering whether they expected this lesson or wanted an escape hatch for finally working on a computer. Maybe a few reflections on this?
Yes, I understand where you're coming from. I think there's a mix. In the Netherlands, they work on laptops a lot, but they also have assignments on papers or in books. I do think it has to do with the nature of the class, because it's a programming class, and I think that's why they really, really hate to work on paper, because it's programming, so we have to do something with computers, right?
Is this on? Okay. So this is about applying natural language education techniques to programming education. Is there any like past work on like cognitively, like the parallels between natural language acquisition and programming language acquisition?
Yes, in the paper you'll also find a lot of related work about similarities between the processes of natural language acquisition and programming language acquisition. And there are some aspects like with more experience, brain activation patterns when reading by more experienced programmers. Those patterns when reading prose and reading code are growing increasingly similar. So that's quite interesting. And also when you're able, there's a relation to being able to learning a natural second language and learning to program. So it all helps each other, I guess.
Yes, hello. Thank you for your talk. One of the challenges in learning a new language or natural language is that ambiguity. But programming languages tend not to have ambiguous statements in them. Right, so how would this influence the approach to programming language acquisition?
Yes, programming language don't allow oh, that's quite a hard word. Ambiguity. That's true, because everything has to be taken literally for the computer to understand it. In natural language, we can have words with different connotations, or similar of the same word can have several meanings. I don't think that stands in the way of applying natural language techniques to education, because well, I think it actually makes it easier, because in natural language you have to explain why a word can be one thing or mean another thing, and in programming language you can just there's a one-to-one relationship between form and meaning.
Yes, but you're using a natural language. But you're using a natural language, right? So I see in your that they underline the word "is," for example, and stuff like this. So there could be ambiguity on what this means.
Yeah, what I really try to do is take a look at the didactical approach in natural language learning and apply that to programming education, because I think there are techniques that can enrich it. But I don't try to prove natural language and programming language are exactly the same. I think there are techniques there that really work and that can we can map, but it's not exactly the same, of course.
Thank you.
Do we have time for one more? Yeah, I think we have time for one more. We have 2 more minutes left. Anyone?
Happy birthday from all of us.
Thank you.